Hello, this is Daphne Christina Nelson, and my register number is URK23AI1033. This is experiment 4 of Deep Learning Laboratory, which is the VGG16. In this experiment, I used transfer learning to classify images with the help of a pre-trained deep learning model called VGG16. The main aim was to understand how pre-trained convolutional neural network can be reused for new classification tasks without training them from scratch. Let's get into the code. For this, let's open our Colab page. Here, as you can see, I began by loading the VGG16 model from Keras, which is already pre-trained on the ImageNet dataset, a massive collection of images across 1,000 classes. Then I modified the model to predict on a new dataset. In my demonstration, I used an example where the model takes an input image such as a dog's photo. So here I have used a picture of a specific breed called Pomeranian, as you can see here. So this is the photo that I have uploaded, and it will correctly identify it as which breed dog is that. The process involves resizing the pre-processing image to match the VGG16 input format, feeding it into the network and decoding the model's prediction. Unlike normal CNNs that we build and train ourselves, a pre-trained model like VGG16 already knows useful visual features such as edges, textures, and object patterns, which allows it to classify new images efficiently and accurately. The model output is for your perusal. So on taking the image, it has clearly classified that the predicted class is a Pomeranian. The confidence or accuracy level is 85.7%, which is not overfitted, and also underfitted, which is correctly fitted with an error of 14.30%. So the model output includes a prediction label with a confidence score. I also calculated accuracy and error rate to evaluate how well the model performs. In this case, the retrained model achieved a high accuracy and correctly classified the input image, proving the strength of transfer learning. Let's get back to our record. So this is my full record of fourth experiment, which contains the aim, description, program, output, and the result. So, in the real world application of VGG16, in real world applications, pre trained models like VGG16 and ResNet are extremely used in medical image analysis, autonomous vehicles, facial recognition, and security surveillance systems, saving both time and computational resources. To conclude, this experiment successfully demonstrates how a pre-trained model like VGG16 can be applied for accurate image classification tasks, highlighting the importance of transfer learning in modern artificial intelligence and computer vision. Thank you for watching.